Hello to everyone, I'm Gabriele. Good evening, good afternoon, good morning. Welcome to my YouTube channel, TESI, a channel for theoretical and experimental scientific investigation. So today we're going to investigate on the force produced by two magnets. So as you know, when you put the magnets close by one together, depending on the polarity, you might obtain an attractive or repulsive force. So this depends basically if the polarity is the same or not. But what is the force and how can we measure this? Well, we can trust on some of the formula that are carried out by using the magnetization vector, which relates the volume to the moment of magnetization. Right, but it's also good to have a validation tool that allows us to be sure that what we are measuring or what we are creating develop the force that we want to develop. So the agenda of today, we're gonna make an introduction. What is it? This machine, some fundamentals for what concern magnets, the benchmark setup for the tool that we are using, and some little experiments results that have been performed by linking the data acquisition systems to the machine that I'm about to show you to the computer and lab view. All right, now what is it, the machine? Okay, the machine basically in this case is a measurement tool. As you can see in the picture, we have a frame actuated by a stepper motor that create a axial motion. There are some components that we are going to also explain in a detailed manner in the next pages. So once we get close with the two magnets, we want to measure the force and at the same time we want to record the displacement, the mutual distance between the two magnets. The goal is to develop an expression or a pattern for the force, and by using a proper also mechanism we can measure the torque, but in this case we are measuring the force. As you know, torque is force by distance in modulus. Then if we want to get into the specific topic with the math, it's a distance cross product force, right? With a proper symbol, with a right or left hand method. Okay, now in the fundamentals, in introductions, we have two substantially develop. Actually, this is fundamentals. Let's say fundamentals. Okay, so everything depends by the polarity. If the polarity is the same, the force is repulsive. If it's opposite, it's attractive. Why that happen? Not even one of the best physicists in this world, and even Richard Feynman in the far 1980s was able to explain. It exists, and there is a mathematical tool that explain that or justify, but the nature actually of this phenomena is still unknown. You can consider, for example, that once you establish the convention that the line from a pole, for example, from the North Pole escape, right? They collide together. So for the principle of the impact, you can use this analogy. They repel, right? Even if they are south and south, they get far away. They hate each other. You can remember like this. Instead, if the polarity is opposite, it goes from one place to another, right? One receive, the other one take it. If you think about the relationship between a man and a woman, it works like that. There's always someone that is more able to receive rather than to give. If both together they clash continuously, that's the reason why happens the divorce. Thank God it doesn't. It's not happened to me. Thank God. Thank God. So, and this is the analogy. All right. So the components are stepper motor, linear axis, upper magnet fixture, lower magnet fixture. Usually these one are the same. Some slightly difference in order to create the connection between the load cell that is on the bottom, right, and this fixture. I develop also just a base to anchor the entire systems on a plane here on a table. I use wood right here because it was the first available material. And then you had to use some sample weights in order to create a very reliable measurement system, right? Then we have a digital linear caliper that is anchored to this little plate with 4 holes that anchors the entire systems to the linear axis. You have a data acquisition systems, then you have some other components that I didn't list here specifically because they are very anyway simple. You can have batteries or a power supply. There is also some components that are missing, which is the Weston bridge, but it's an intermediate component that is right here on the board. I didn't take the picture, but I will show you the machine. Actually, the machine is in the back. It's right here. Can you see it? There you go. I will get close the camera and then I'll show you what is this. Okay, let's move forward. What I have designed basically is this green component, this cyan, how you pronounce this? Is cyan? Okay, violet, this a little L-shaped flange with the 3D printing. Okay, but this, and this has been sent out after I have produced some drawings and sent it to an external CNC manufacturer. The rest of the component have been purchased online on AliExpress. It comes roughly no more than $200 to make these things. Okay, then we have also the load cell that I purchased. Actually, I don't need this slide. Oh no, probably I need. You know what? Yeah, I don't need these slides. And then I'm gonna put like this one, like this, and this still under design. Yeah, the video is fresh. I just finished to prepare that. All right. Simply connected. I didn't do any dramatic or rocket science engineering. Well, let's say that. As someone says, I'm a manager of a system. I just purchased this component online, assembled together, and try to make as much as possible the entire system similar to one of those expensive UTS machine. For what concerns the wiring connections, we have a load cell with 5 cables. One cable is the shielding to prevent the external magnetic field that can create perturbation in the power supply and also, and above all, in the signal coming out from the load cell. So once this signal basically are injected here through this wave transmitter, then the output is connected on the DAC system. So specifically, the excitation plus goes in E plus, excitation minus goes in E minus, signal plus goes in S plus, signal minus goes in S minus. The wave transmitter, which is a Weston bridge, is powered by 12-volt power supply, where plus and minus in this plug goes straight into here. Plus and minus. Remember, this is not ground. Remember that Weston bridge doesn't have any ground. All right? It's also differential voltage. The output, the V, goes into the red wire in the DAC systems, while the P minus, okay, it's the lower voltage, goes in the blue wire. The DAC is configured in a differential mode, not ground, or RAC, reference single-ended. Okay, if you want to see the video, just connect on this. And now, if you don't have any questions, I will switch directly to show you the machine. So let's go right here. All right, so we have this component, which is the wave transmitter. Then we have the national instruments here. The load cell. Careful to this load cell. Careful. You don't have to flush the entire systems on the bottom, because in the moment you tight, you are sucked in the thread and alter the measurements. What I did, I just put a nut on the top and a flange on the bottom, so every time I push down, only the thread is pushed up, the rest stays down. Even on the bottom right here, it's been done the same thing. This is an axial compression and tension load cell. If I go right here, now you see this wire. I will prepare a video on how create the system completely automated by a joystick that can make this part completely electronic actuated, so I can go down and up at different speed. Now if I go here rotating, see that? I can go down, and at the same time, so the linear caliper registers the displacement. This component is very interesting because it can be connected to a computer through a cable. So every time you want to record an Excel file, you just push a button from the load cell from the screen in the lab view. You can associate the force and at the same time the displacement. And some other components that allow me to create a more stable fixture on this plane, which is a wood, very nice, I like it, is this rod. These are the same rod that are used on the car sports shop to make more stable the wing installed on a vehicle, on a car. So in this case, basically they absorb the compression load when I go like this. When I go down, so this one react up, so it tends to bend the structure like this, but this one sustain the load. This one instead create a more stable position of the entire actuator on the plane. Another thing that is necessary to say and is the power supply that has to be connected to the weight transmitter, and also the magnet that are manufactured in order to have different shape. So you can take, in this case, a round magnet, or you can take the rectangular one. So this plate has been manufactured as per drawing shown in the PowerPoint. Another thing are the standoff. Since the shaft of the motor was too long, that was colliding the threaded shaft, I used the 6mm standoff attached to this motor to prevent that the head of the motor collide on this. Another thing that I was about to say is this base. This keep fixed the entire load cell on the plate, and the system works perfectly. It is a very useful system. Allows me to develop the calculation of force, and it was very useful. What else to say? Actually, I'm very satisfied. If you have any questions, guys, don't hesitate to contact me. Another thing, this can measure so also the attractive and the repulsive force, because this is axial. Actually, I had to fix this one. As you can see, I put some oil because I was modifying the position. And what else? I think that is it. Yes, this is very useful. Okay, prevent to install the part in a wrong angle, and also for this one to avoid that the displacement is not the one they were looking for. Some of the components have been also 3D printed. It's not a problem. So there you go. Oopla, every time this camera I have to make it more fixed component right here. Let me see if I don't crash it. Alright, from Tesi, that's all. Let me know if you like it. Make a thumbs up and send me some email if you're interested in some if you want to ask me some question. I will be very happy, This the PowerPoint presentation can be fixed a little bit, but I think it is very clear. All right, guys, thank you so much, and have a good day, good afternoon, and good evening.